How do you do? My name is Frank Goldner. I'm the program manager of the Accident Tolerant Fuel Program. I'm very pleased to have with me Janelle Eddins, the program manager of Advanced Reactor Fuels, and Ken Keller, program manager of Capability Development. Since we all work so close together, we're going to do something a little different in this presentation from others. We're going to give our presentations one after the other, and then we'll all be here if there are questions, since we have more than a half an hour, almost up to an hour. So I'm very pleased to whoever is on the line. People we will mention as our managers in the field are listening in, and they can chime in as necessary or be around for questions. So I also want to thank ahead of time all of you who are listening in. We think we have a very exciting program, and I think probably most of you will know about it. This first slide, I'm showing you the general structure of the overall Advanced Fuels campaign. As you know, I'm sure, we have three major areas that we deal with: accident-tolerant fuels, which you know about, and how we can improve LWR reactor safety and performance. We have advanced reactor fuels, which to me is very important because it deals with the future and trying to get a better performing fuel and concepts. And then we link them together. We have quite a bit of work to do, on how we support the development, how we characterize, et cetera, instrumentation. We're doing very exciting things. At the very last slide, there is a linkage to our last year's campaign program, what do you call it, to the annual report of the campaign. In that report, you can see lots of reports by the various people in our campaign for all of these areas. So there'll be some linkages at the last slide that will let you get more information. Also, I would say you can go into the NEOP site and get information there. Now, the third big area on the right is this fuel product line under the NEAMS program. Very important, we think, is the modeling that will be used for now to support us, but also for the future. Okay, so that's the, okay. In the slide, we listed here the FY18 NEOP awards, just so you can get the look and feel. In past years, some of us have tried to focus on certain technical challenge areas. Like in my area here, I was interested in what happens with silicon carbide. And we focused all of my area, which is 2.1, in silicon carbide. In the other two areas, they focused on areas that they think are very important to their program. And you'll hear from Janelle and Ken when they talk. I also would suggest going into the site and looking at even further past ones, because the year before, I had one on critical heat flux, just one important technical areas. So we're trying to support our programs, and the universities are very important because you train the young people. You also work on what we're programming, so you help what I call relevance, which is a major factor in how I look at it. So I'm now going to start with two areas in what's called 2.1, which I think universities should find very interesting. The first one is PIE, post-radius examination, and non-destructive techniques that can be applied to a very difficult area for modeling and other things. And that's thin films that occur either because we put them on there, like with chrome on Zirc, or they occur just because of conditions in the coolant, which might happen with some of the metal things. I've just listed coated ZR, Fy19, which is one of the iron-based coating clads that's being considered, and silicon carbide, which is a very new type of coating. So in this proposal, from suggested and pursued by Jason Harp of INL, we're looking for ideas that can go beyond what's done now when you want to characterize a coating. And the trick is, they should be hopefully applicable in a radiation, so in a hot cell or something like that. So not only are we interested in expanding the field of characterization, measurement, understanding thin films, on claddings or as may be deposited. But we're also interested in how you transmit signals and measurements that you make in this hot cell, let's say. How do you get that signal out? So that's also very important. So in this area, it sounds like it's old hat making measurements, but as you know, thin films or coatings, which might be in the micron level or less, they're things that are micro cracks. We worry of what the coating delaminates, and so this is something we'd like to apply to irradiated materials. Just on this slide, look at the bottom. From a point of view of relevance, we would look very favorably if you show a recognition of understanding of existing ATF cladding vendors, which I'm sure you all know that we have three main ones pursuing coatings on Zirc, a different type of clad, or silicon carbide, or combinations, So this is an exciting one. The second slide just further digs into it. As I said, the focus is on existing claddings that we're considering. This work will be very important to what we're doing now. We already have things under irradiation in ATR, and we're planning transient reactor test facility irradiations. They just about started, and this is going to be could be terribly important to the future of nuclear in whether some of these claddings of ours may improve the situation of margin to failure and things like that. And TREAT will be a very important device for looking into that. So again, this work is very important and relevant. The second, coating adhesion, oxide thickness, these are all things that we need to know more about than we do now. I'm not going to dig into the various sub-bullets, just point it out. You can read it here, and you can read it in the documented call. And you can look at our annual report and see what's been done in the last year that might be relevant. And of course, you have an email address on the last page of the document also of the people who back up all of our presentations. And they will be pleased to hear about questions, even if you don't bring them up now. So again, we give priority very high to show a recognition of relevance to existing programs. Of course, if it's so new that it has to be developed before one fully understands the relevance, I wouldn't throw that out. But we don't want to dissuade against coming up with something rather new that may need a couple of years to prove its relevance. I think I could find it interesting, but obviously we'll have to see. So that's my first of the two areas I'll talk about. The next one is an extension, as you know, for this accident-tolerant fuel program, which started with a congressional mandate in 2012, has been focusing almost exclusively up to now on fuels with enhanced accident tolerance. However, there are people who worry that even if the fuel should survive and you have a severe accident where everything melts, if the fuel columns are standing and nothing else is around, nobody's interested in what you got. So we've always recognized that there are other things in the reactor beside the fuel, specifically stuff near the fuel, like control rods, if there's shrouds or not, thimbles that have instruments and flux wires and stuff like that. And even the next level out, I don't know, the core support area, there are things that are not replaceable. And this one, as suggested by Dr. Michael Tedoso of B&L, is looking at ideas that could apply to other parts of the core area. We already have, I think, a past SBIR. There are some parties looking into this, but we wanted to open a door for some basic thinking, okay? And we're interested in both experiments and analysis, even though that's what we have underway. You should know from reading the background and references, the three teams. Obviously, they're all interested in it, so there's no problem with checking in with members of the teams, although Mike is probably a very good lead contact. Go first to Mike if you want clarification on this. But basically, we're looking into beyond design basis accidents, but we can't rule out benefits or relevance to normal operation. You know, there are things that are important. Anticipated operational occurrences, design basis accidents. Obviously, you don't want to have something that's great for if everything goes to pot, and all of a sudden, when you have a quench or something like that, your solution falls apart. So although this is an accident tolerant fuel program, uh, you can't just look at the beyond design basis without recognizing that especially new ideas may affect the existing. So that's a good topic I would suggest as you develop your ideas, touching base with Mike, or all of us are available. I'm going to stop for now and then just say, well, we're going to go continuously now. So if you have questions, please send them in, and they'll drop them on us at the last minute. I think we all like to leave lots of time for questions, so we're not going to use up the whole time for sure. Uh, we look forward to it. So we're trying to be focused in my area. I think the other two areas you may have different scopes. They may be wider, broader, uh, because we have this near term. Just for your information, uh, our three lead accident tolerant vendors are all hoping by the mid 20s, 2020 time period, 25 or so, plus or minus a couple of years, that they will have been to the NRC with their ideas. So anything really new, hopefully, either they're interested in bringing it in with the initial contacts, or as they go on to future, because you don't just load up a whole reactor at one time. You begin with a part, and you take several years to get, and so there'll be lots of interaction time in my area. So I'm going to turn this over now to Janelle Edens to tell you about her exciting work. Okay, you're 2-3, huh? What? Oh, yeah. So thank you very much for listening in and taking time, and I look forward to your letters of intent, which I'm assuming and hoping. No letters of intent? All right, they say pre-application. Okay. Well, for me, I'd like to treat them like, try out your ideas. You don't have to be finished in that pre-application. You know, just put enough so we can figure out its relevance and its interest. Thank you.
Hi, good afternoon, everyone. Like Frank mentioned, my name is Janelle Edens. I'm the program manager for the Advanced Reactor Fuels area. And Frank presented the two ATF specific work scopes. I'm going to present the two Advanced Reactor Fuels work scopes. So first we have FC 2.3, which is investigations into non-traditional solid fuels for advanced non-LWRs. And the technical point of contact is Andy Nelson at Oak Ridge National Lab. To provide some background, there are a wide variety of advanced reactor concepts that are currently under development, and each of these concepts have their own associated fuel. And so some of these fuel types have received extensive research, like MOX fuel for fast reactors, and then other concepts like U-moly fuel has received less study and research. So the purpose of this call is to address these lesser known or lesser studied fuels and to attempt to solve a challenge associated with these fuels by using modern experimental and modeling and simulation tools. And so going into what will be required for the work scope, the fuel concepts proposed must support one of the Gen 4 reactor concepts that are listed on the slide. In terms of irradiation testing, it could be beneficial for some areas, but it's not required. And there are two reasons for this. The first, we know it might be difficult for the universities to complete irradiation and PIE in a 3-year time period. We also know that not all universities have access to irradiation capabilities. So one thing I will point out here is that ion beam irradiation is also an alternative to neutron irradiation, since that's usually more easy to access and easier in terms of PIE. And finally, priority will be given to proposals which include both experimental and modeling and simulation activities. Moving on to the next slide, your proposals must include a brief description of the fuel and its application and what reactor type it will be used for, which challenge will be addressed, and how addressing the proposed challenge will further the development of this fuel, and clearly define the research objectives, timelines, and deliverables. Some examples of fuels that we will consider are the less studied fuels such as U-moly, uranium carbide, uranium nitride fuel. We will also consider TRISO-like or encapsulated fuel that go beyond the traditional TRISO fuel currently being studied by the AGR program. Fuels that will not be considered, we won't consider well-developed fuels like MOX fuel for fast reactors. No thorium-based fuel concepts will be considered, and no light water reactor fuel concepts will be considered. And finally, proposals that focus on reactor design activities will not be considered. So moving on to the next work scope area, FC 2.4, which deals with creep testing for advanced cladding applications. The technical point of contact is Dr. Stu Malloy from the Los Alamos National Lab. To provide some background, long-term use of fuels for advanced reactors can lead to thermal and irradiation creep. And in light water reactors, creep can contribute to dimensional changes on the accident scenarios. So typical out-of-pile thermal creep testing takes a very long time, many years, and it requires large size specimens. And despite these time constraints, there have been significant testing done on some of the older alloys like HT9, Me957, and of course traditional ZIRC for light water reactor applications. So the purpose of the call is twofold. First, we would like you to suggest an improved creep testing method that would require less time to complete and also potentially use smaller size specimens. And then we would like you to apply this improved method to some of the newer alloys like 14YWT or improved heats of HT9 or some of the ATF concepts like FICROL. Priority will be given to proposals that show how the data will be incorporated into relevant multi-scale models. And for the Advanced Fuels program, we're most interested in the Moose Bison Marmot Fuel Performance Code. It's beneficial but not required that the proposed method can also be used to measure irradiation creep in situ. And finally, for the light water reactor cladding concepts, we're only interested in ATF cladding concepts under study by the Advanced Fuels campaign. And with that, I'll turn it over to Ken Keller.
Okay, hello, I'm Ken Keller from the Department of Energy, and I'm going to talk about our grant opportunity FC 2.5, which is titled Separate Effects Testing in Treat Using Standard Test Capsules. Our technical point of contact is Dan Walks from Idaho National Laboratory. Eligible leads are university only. This is a combination NEUP NSUF, so it's up to 3 years and $500,000. And NSUF access request is required. The idea here is within the 3-year period, you will set up an experiment or a series of experiments to run in the treat reactor, run them, and have your analysis and conclusions at the end of the 3-year period. So more specifically, DOE is seeking nuclear fuel development strategies that rely on integration of microscale material science and thermomechanical engineering through advanced modeling and simulation techniques. So our interests are twofold, and our interests are in developing physics models that provide input to the codes, as well as integral system data to be used in validating the results of the simulations. So let me expand on that. You can use this grant to explore fundamental physical phenomena, and we're focusing on microscale. Or you could also, if you think there's a mature model, set up an experiment to validate that the modeling is accurate. You would predict the outcomes of your experiment, model it, and then compare the actual results of the experiment to what your model is going to predict. The image on the right shows basically what you're going to be dealing with. It's very small test capsules, and I'll go on to the next slide to talk about that a little more. Proposals are sought that will leverage the treat's minimal activation reusable capsule holder called MARCH. It's an irradiation testing system, and you can see the drawing on the right. You have a small capsule that is what will hold your experiment device. The march itself is really a long steel pipe, and that is the safety boundary for the experiment, and it will also have penetrations for any diagnostics. And then there's an outer can, which is really just a convenience holding can to be a nice package to go in and out of the reactor. So we expect 2 test vehicles. We definitely expect the March Seth, which is a dry option, to be available to you, and perhaps the March Serta option may be available when you contact Dan Wachs at INL, which would allow liquids. Some examples of the types of experiments we're interested in are listed here. In situ evaluation of physical properties of physical material while under radiation, thermomechanical response of fuel system components to nuclear heating, and short-term microstructural evolution of fissile materials under radiation. We anticipate, it's not required, but we anticipate you'll be using the IMCL, the Irradiated Materials Characterization Laboratory, to prepare and analyze your samples. We're anticipating you have a sample where you would evaluate the microstructure of a sample, irradiate it briefly, and then reevaluate the microstructure of the sample. That's basically what we're looking at. Now, as far as risk that we're willing to take on in DOE, we are having low tolerance for risk for running your experiment. So, for example, if there was any risk in your proposal in preparing the sample, that will probably not be accepted for NSUF. We have the materials library, which already has samples that are readily available. Or if you, the proposer, have a sample that we can characterize and be confident we can use, that would be more likely. We can accept risk in your modeling that we understand risk that you might not be able to evaluate the phenomena and establish a clear model. That type of technical risk, as far as getting results, we're open to that. It's just, but you have to have very high certainty that we will be able to run the experiments, to actually run the treat shots. So there's a great opportunity. The treat is just up and running. The March device is being proven in as we speak. So you can be one of the first users of treat, and the March test device, as well as use all the really cool stuff at IMCL, scanning electron microscopes, focused ion beam to prepare samples. This should provide a really broad array of experience to anyone who gets this grant. And with that, we're prepared to take questions on all of the 5 offerings. Please, in your questions, specify which offering, FC 2.1 through 2.5, that you have a question.
Yeah, thanks, Ken. So we'll have all 3 program managers here, and we're going to take a minute or 2 to get the technical points of contact, their mics unmuted so that they can answer questions as well. As Ken said, please do note which area your question is for, and then we can direct that toward the individuals involved. So please give us about a minute to work to get everyone's mics open. So Frank had a suggestion here before we get going with questions. Do any of the technical points of contact want to make any additions? We can.
Let's go through the order, okay?
Yeah, FC 2.1.
Jason, would you like to add anything to what you heard?
No, I don't think so. I think you explained everything, Frank. I think it's more just specific questions at this point.
Mike Tadoso?
I would agree. I think you did a good job. Any question specific can follow on.
So Andy Nelson would be.
Andy Nelson?
Yep, I think Janelle did well. Thanks.
Stu Malloy?
No, I don't have any other things to add. Thank you.
And Dan Wachs?
Yeah, the one thing I would say is just to reiterate a point that Ken made, that give us a call, and if you have some ideas and want to talk them through, we'd highly encourage you to integrate with us early in the development of proposals related to the treat vehicles. There's some nuance and opportunity.
And last but not least, Steve Hayes.
No, I think the introductions have been good. We're happy to take questions.
Okay, let's get started with the questions then. Frank, we're going to start with you on ATF. What are the 3 ATF vendors that you referenced?
Okay, the 3 vendors are Framatome, whose prime concept is a coating on their zircaloy form. Westinghouse, who's considering both coating on zirc, but also has the prime interest in silicon carbide related cladding, which is a composite of more than one item. It could be SICK, we talk about it. Okay, and then General Electric, their prime one is this new iron called Fy19, iron chrome aluminum combination. That's their prime one that they're looking into.
For FC 2.1, non-destructive examination techniques. Can you explain why the signal is difficult to be transmitted out?
Jason, would you like to answer that?
Sure, I can answer that. So the measurements need to occur inside the hot cell, and so the difficulty is that the signal needs to pass a significant distance, about 30 feet, from the measurement device to a data collection computer, and then the signal needs to pass through a hermetically sealed feed-through, and so there are certain things that just won't work with that. So, for example, USB 3.0 this is not amenable to being converted into a hermetically sealed feed-through, and also typically will not work beyond about 10 feet of cable length.
Thank you, Jason.
So I'm going to guess that this is a question for FC 2.5, but I may be wrong. For the advanced creep testing, do you have a preference on the type of loading?
That's probably Janelle.
That would probably be, okay.
Let Stu handle that question.
Yeah, well, my preference is to have the loading in tension. I'm not sure what they're asking for here, whether it's strain versus over load control. I don't have a preference over that, but so if they have more clarification, they can provide it. But
as a separate question for FC 2.4, how much weight will be given to an industrial collaboration?
We usually like to see industrial collaborations because that shows that there is a concept, but that's not the primary consideration, but it would be given weight in terms of the partnerships.
As a procedural comment to that, there is a 5-point bonus, potential 5-point bonus that's given to strategic partnerships. Those include minority serving institutions, underrepresented groups, industry collaborations, and international collaborations. So there is a small point value added on to relevancy reviews for that category. So going on, following FC 2.4 again, multi-scale models typically need to be tuned to a specific material. What specific materials are of interest for the accelerated creep testing project?
So I think we give a few examples in the work scope. It's alloys that have not been fully studied, like the ATF concepts, also of the more advanced ODS concepts like 14YWT. Also, there have been advancements to HT9, so any new heats of HT9. So pretty much it's any alloy that hasn't been extensively studied before, like no traditional zirc for light water reactor fuels or anything like that. Do you need to add anything, Stu?
yeah, that covered it quite well.
Move on to some FC 2.5 questions. does FC 2.5 require modeling and simulation as well as irradiation studies in the proposal?
Technically, no. Regarding modeling and simulation, we're looking for the discovery of new physics, new phenomena that will ultimately go into modeling and simulation. So it'd be very satisfactory to do physical experimentation, measure phenomena, characterize them with formulas in mathematics, and be done, and never touch a computer. Dan, are you on board with that?
Yeah, I think it's not necessarily a requirement, but it's nice if you can identify the analytical impact the experiments might have. But some cases, it's exploratory.
Oh, and here's another thing. If you identify ongoing DOE codes, that this would help. You know, that would get our attention.
Also for FC 2.5, do materials need to be fissile or can they be surrogate systems?
Yeah, it's open beyond fissile. That you can have, yes, propose it. You could have surrogates and non-fissile materials. Just keep in mind, we're looking at separate effects and fundamentals, and surrogates. We would give priority to direct materials that are used over a surrogate unless a real strong case is made that this surrogate is essential to develop some code, and you'd have a bigger burden to show usefulness to DOE.
Yeah, so to add to that, I think you know the advantage of being in treat is that you can take advantage of nuclear heating. We do experiments using you know, borated experiments to generate that heat. But typically, if you're not using a non-fissile material, it may not get any advantage from the nuclear exposure.
Frank, moving to FC 2.2, how important is thermomechanical analysis of potential advanced components in LWRs?
I would think, I'll ask Mike to chime in, but I think you couldn't ignore such considerations if you're looking at new materials or new combinations of materials. You know, a control rod has to be handled, and it also has to do its job. So there might be more than one type of material. So I think thermomechanical knowledge might come with the turf for that. Mike?
I agree that that's really very much related to the functionality that we talked about in terms of being able to insert and withdraw control rods during normal operation as well as under the accident conditions.
Follow-on question to that question, is both modeling and experimental work preferable, or is it acceptable to do one or the other?
I think it is acceptable. Obviously, a paper design would not be, in my opinion, a high priority activity. So I think it should be something that either can be reduced to some kind of design test, or at least be convincingly that it could be. But I would certainly frown on just a paper idea because there's a lot of that. So I would hope it would be something that's reducible to something that can be fabricated. And modeling, I don't see, you know, obviously that's not ignored, because if you're going to have a different type of material that behaves better than, let's say, boron carbide or something like that, you know, it's going to have different physics. And that's why in the call, Mike wrote in words like neutronics and thermohydraulics. So it certainly requires some degree of modeling ability, or at least knowledge that how it fits in. Mike?
Agreed.
Thanks.
There's only one more question, and I'll provide an answer to this. The question is, can you please summarize the procedures and dates for getting approval from NSUF prior to submitting an NUP pre-application? And I do want to remind folks on the line that the two work scopes that are NSUF related in the Appendix A for this FOA are the NEAMS 2 work scope and this FC 2.5 work scope. So both of those are only for university applicant leads. and they both do require NSUF access. There is a letter of intent requirement for the NSUF projects. So what will typically happen is when the FOA releases, there's about a 2.5 to 3 week time period to submit that LOI. That LOI must be submitted to the NEUP.gov website to be considered further. So you'll need to get the LOI in. That will give NSUF a heads up that you are trying to work through the NSUF process, and will help them get a head start on feasibility reviews for the project. About 3 weeks after that is when NEUP pre-applications are due. So be aware, whenever the FOA does release, there's about a 6-week time period before pre-applications are due, and half that time for the letter of intent. So I'd like to thank our entire crew of people for being here on board. Frank, Ken, Janelle, all of the TPOCs, we appreciate your time. We will encourage you to continue to talk to the federal points of contact and the technical points of contact going forward. We do have 2 final presentations for the day before we wrap up the webinar. Our next presentation will be on the IRP NE1, which is our Grand Challenge IRP. That will take place at 3:30 p.m. Eastern Time. Thank you.